on questions 11 and 12, you can solve the system that works best for you. The only thing is, make sure your answer is exact answers. I don't want any rounded decimals. In other words, unless your answer is a whole number, let's not use graphing. Now, on question 11, let's take a look at that one specifically. Notice there are nice columns for us, so I think what we'll do on question 11, let's use elimination. And I notice that for my y's, one's positive and one's negative, isn't it? So they will cancel as long as I have the same number in front. So in other words, let's take my first equation and let's multiply that by 10. So we get 30x minus 10y equals 1490. And my second equation is 25x plus 10y equals 2415. Well, I add them up, I get 55x. Notice what I wanted to happen, my y's, they're going to cancel out. And then we're going to add 1490 and 2415. So 9 plus 1 is 10. 5 plus 4 is 9. So I get 3905. To solve for x, I will divide both sides by 55. 3905 divided by 55. Let's go ahead and do that. 3905 divided by 55 gives me 71 for x. Well, that turned out to be a nice whole number. Let's see if y gets the same thing. I think I'll use my first equation again. So I'm going to go 3 times 71 minus y equals 149. And then 3 times 71 is 3 times 1 is 3. 3 times 7 is 21. So 213 equals 149. So let's subtract 213 from both sides. So I'm minus 213 from both sides. Since 213 is bigger than 149, my answer is going to be negative. So negative y equals negative, and what did we get there? 64? 13 minus 9, yeah, 64. Since negative y is negative 64, y is positive 64, 71, and 64 is our solution. And we could have done that by graphing, because that one turns out to be a nice whole number, doesn't it? But I told you not to do that, so that's what I would prefer you do. Now let's take a look at problem number 12. We got fractions galore on here. So let's first off, let's rewrite the first equation so it just has fractions, not mixed numbers. So 8y equals 3 halves minus 2x. And so I think what we'll do is we'll multiply that whole equation by 2. That way we don't have to worry about it. 16y equals 3 minus 4x. The second equation, you only have one fraction, it's 3. So I'll get x equals 6y minus 3. Now, that one is set up, I think, for substitution because x is by itself. So let's rewrite that using substitution. So my first equation is 16y equals 3 minus 4 times 6y minus 3. Now, let's distribute that. So 16y equals 3 minus 24y. Negative times the negative is a positive 12. And so simplify the right side there, and we get 16y equals 18 minus 24y. Well, let's get all the y's on the same side, so we'll add 24y to both sides. And we get 40y equals 18. Divide by 40. And notice, what can I divide by here? I can divide, oh my goodness, what's 3 plus 12? Dum dum dum. That's 15. Whoa, I didn't mean to do that. Let me see if I can make this a little bit smaller. Okay. There we go. So I want 15. 3 plus 5 is 15. And then I divide by 5. 15 divided by 5 is 3. 40 divided by 5 is 8. So you get 3/8 for y. Notice, could not have done elimination, or graphing, I'm sorry, with that one. You could have done elimination, but you couldn't have done graphing because you get a fraction for an answer, and that won't tell you 3/8. It'll give you a decimal unless you know what it is. So now let's find x. So x is 6 times y, which is 3/8. And then we are going to subtract 3. Well, let me see. 6 and 8. 2 goes in there, so I get 3 and 4. 3 times 3 is 9 over 4 minus 3. And then you need a common denominator. 3 times 4 is 12, so 9 minus 12 over 4 gives us negative 3/4, doesn't it? So then our solution is going to be 3/8 and negative 3/4. Okay, on our next ones, it's fine to use graphing as long as we get a whole number. And we have to do some transforming from verbal to algebra. So 3 times one number, well, let's call the first number x, added to 5 times the second number, call that one y. So we'll say 5y plus 3x equals 68. 68. I don't like the way that 8 turned out. Let's try that. Okay. And then 3 times the second number. Oh, they like to put the second number here first. So 3y minus 4 times the first number for x equals 6. Well, let's get rid of the x's. Let's use elimination because they're nice columns. They did that nice for us. So the first equation, let's multiply that by 4. The second equation, we'll multiply by 3. So 4 times 5 is 20y plus 12x equals 68 times 4. I mean, 60 times 4 is 240. 8 times 4 is 32. So we get 272, don't we? And then 9y minus 12x equals 18. Now let's combine them. 20 plus 9 gives us 29y. My x's cancel. That's what I wanted to happen. And then equals 272 plus 18 is 290. I'll divide both sides by 29. Y gives me 10. And so it's my second number is 10. Let's go back and find my first number. Let's use our first equation. So we're going to say 5 times 10 plus 3x equals 68. So 50 plus 3x equals 68 minus 50 from both sides. And we get 3x equals 18. I'll divide both sides by 3, and x is 6. So my two numbers are 6 and 10. And notice they're nice whole numbers. We probably could have solved this just by graphing, but I wanted to go over that with you.